Hello and welcome to EMC Live. We kick off this special event with a keynote presentation, saying goodbye to wires and hello to a more efficient approach to powering up. My name is Belinda Stachukevich and I'm the editor of Interference Technology, the creator of EMC Live. EMC Live is a brand new online 3-day event hosted by Interference Technology. Featuring practical information and topics, this event will include roundtables, webinars, and videos on everything EMC related, and there's no cost to attend. Join us for our other webinars and roundtables all this week. EMC Live's platinum sponsor is Rohde & Schwarz. Rohde & Schwarz is one of the world's largest manufacturers of electronic test and measurement, communications, and broadcasting equipment. For more information, visit www.emc.rohde/schwarz.com. This keynote address today is presented by Kaynam Hedayat. Kaynam is the Vice President of Product Management and Marketing at WiTricity, where he is responsible for defining and driving the marketing, product strategy, and direction of the company for the entire WiTricity product line. Kaynam is a 20-year industry veteran and lead author and co-author of several standards and is co-holder of several patents. Additionally, he is co-author of the book, Multimedia Systems, Standards, and Networks. He has a Master's of Engineering degree from Cornell and a Bachelor of Science degree in Electrical and Computer Engineering from Northeastern University. WiTricity was founded in 2007 to commercialize a new technology for wireless electricity, invented and patented 2 years earlier by a team of physicists from MIT. Visit their website to learn more. This keynote speech today will be interactive. You will be able to ask questions and we encourage you to participate. Take a look at your GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimized and maximized, click the arrow button. To raise your hand to ask a question or to report an issue, click the hand icon. We will present the topic for 30 minutes. Now Kaynam will begin the presentation.
Good morning and good afternoon, wherever you might be. Welcome to this presentation. First, I'd like to confirm that everyone can see my screen and my slide. I assume it is up and running, Belinda?
Yes, everybody should be able to see everything. It looks good.
Perfect. All right, today I'm going to spend about half an hour with you and give you an overview of a very new and exciting technology that we refer to as WiTricity, short for wireless electricity. And the topic that I have today is wireless electricity, safe, efficient, and over distance. So to kick off the presentation, I like to always ask folks that why is it that in the age of wireless, we are still tangled by a lot of wires, namely the power cords. I look around my office and my home, and wires are everywhere. And you always ask yourself, why is that? Why do I have to pack all these wires with me when I travel? And why do I have to concern myself all the time on which wires and which cables I have in my car to charge my phone? The other question I always like to ask folks is, why is it that we love disposable batteries so much? Disposable batteries are a big waste, both for the industry and in terms of energy efficiency. If you look at the total cost of ownership of a disposable battery versus rechargeable battery, you will see that the cost difference is over 300 times. The cost of a disposable battery is 300 times, over 300 times more expensive than a rechargeable battery. So why is it that rechargeable batteries, they have only 10% of the market share of the total batteries globally in the form of AA and AAA and so on? And the answer is fairly clear. The answer is that we love power. We live by power. If there is no power, we can't move on. We can't go on in terms of power cords. And in terms of batteries, to me it was interesting. I really didn't know why, but then I looked at myself and the way that my family lives, and I think it's a lot about convenience. We don't want to take that rechargeable battery out every time, recharge it, and then put it back into the device. So we love disposable batteries because they are very, very convenient. And that's where we come up with a concept of wireless electricity. What if there was a technology that you could safely and efficiently charge devices or transfer power for different applications over distance? This is where WiTricity was born, based on an invention out of MIT to transfer power over distance. Now, a lot of folks, they tell me, well, wireless electricity has been around for over 100 years. What is different about this new technology? And technically, you are correct. Michael Faraday invented induction over 120 years ago. The only challenge with induction has been that to transfer power, the device that provides the power and the device that receives it, they have to be very close to each other, almost touching, and they have to be exactly aligned. So that positional freedom, or that freedom of usage, becomes basically non-existent. A great example of inductive technology is the wireless toothbrush that many of you may have at your home. And you notice that the wireless toothbrush, it is wirelessly charged, but you have to put the toothbrush on a stem that aligns the receiving unit of the power, which is the toothbrush, and the transmitting unit, which is the stem or the base, closely aligned. You can't really put the toothbrush anywhere around the sink area and have it charged. And the reason is that it is using induction. So the technology that I'm going to talk to you about today is called magnetic resonance, and it provides charging over distance with 4 very distinctive benefits, technology benefits over the magnetic induction that exists today. I'm going to start from the top left of the slide that you see. First is flexible orientation. If there is a source, the source is the device that is providing the energy. And then there's a capturing device. The capturing device with this new technology can have flexible orientation, meaning that you can move it around space, around the source, and it continues to charge. The second benefit, which induction cannot offer, because induction is a one-to-one technology due to the requirement to be exactly aligned, the device, one source can charge one device. In this new technology, if you have one source, since it is magnetic resonance and we are charging over distance, we can charge multiple devices simultaneously. The third benefit, which is, in my view, the most important, is that with this new technology, you can charge devices and you can transfer power over distance, meaning that you can put a source, which is transmitting power, under a table, across a window, or behind some wall, in home applications underneath a granite table. And you can put any device on top of that surface and transfer power through that surface, basically wirelessly charging over distance. And the last benefit, it is something that I encourage you to see in person, because it is truly magical the way it works. It's a concept called resonant repeaters, which is these devices that are passive. They are basically very passive electronics, no intelligence in them, that by their nature, they hop power from one location to another. Think of them as Wi-Fi repeaters in a way. And with that, you can extend the distance of power transfer. The typical distances that we worked with in magnetic resonance without the repeaters is anywhere from 5 centimeters to 30 centimeters. With resonant repeaters, we have demonstrated transfer of power over the distance of meters. And we have some really cool applications in terms of wiring up an entire room without wires. Now, this was the technology benefits. Let me explain to you at a high level how this new technology works. It is important to understand how it works, because then it feeds into the design and how that design applies to different environments and different markets. So the way it works is really built around three fundamental laws of physics and electronics. First, we start with resonance. I'm sure many of you know what a resonator is. A resonator is any system that transfers energy between two modes. The simplest form of a resonator is a child on a swing. If I put my daughter on a swing and I push her, she goes up in the air and then she comes back down. Now, as she's oscillating back and forth, when she's up in the air and she stops, she has a lot of potential energy. As she's swinging down and she comes to the lowest point, she has the highest dynamic energy. And then she goes back up, she has potential energy, and comes back down, dynamic energy, and so on. Another form of oscillator is the wine glass oscillating based on sound. The famous opera singer being able to break a wine glass is the same phenomenon. The wine glass forms as a resonator where the energy is transferring between sound waves and the energy in the glass. Now, a couple of things about resonators. One, resonators have something called a quality factor. If a resonator has high quality factor, it means that it loses very little energy. So going back to the child and the swing, if that swing has high quality, means it has very low loss in friction, and that's assuming there's no air friction. Also, in theory, if I push my daughter, she could swing forever. But in reality, there is some loss based on friction and friction in the air and so on. The other aspect of a resonator is what is called its frequency, or its natural frequency. Again, going back to the child swing, if you remember, to get the swing moving, you have to kick your leg to go up, and then when you come back down, if you want to go up, and you kick your leg again, and coming back down, you kick it back. Without knowing it, you were kicking up and kicking back down at a frequency that was the natural frequency of the swing at the speed that you're going. So every resonator has this frequency that it oscillates at. Now, we take the concept of the resonator and the resonance and apply it to something called a magnetic resonator. Now, this is the electronics part. If you build what is called an LC circuit, so you have an inductor and you have a capacitor, and you excite it with some electrical energy, that energy stores in the capacitor in forms of electric field, and then that electric field discharges into the inductor. The inductor, based on the laws of physics, generates a magnetic field around it. And then you get this oscillation form going between the magnetic field and the electric field, back and forth. And then you take this resonance of the magnetic resonator, and you build two resonators that are operating at the same natural frequency. So you have to build the two resonators at the same frequency and build it with very high quality. High quality meaning that it has very little loss in terms of the electric going to magnetic and back. With that and some very interesting physics behind it, you all of a sudden can transfer energy over distance, even if you have very low coupling of magnetic field between the two resonators. And the way I think about it is that the way these resonators are designed, very little energy from one to the other can be built up over time. It really builds up the energy, and all of a sudden you have this flow of energy between the two. Now, just very quickly going over the physics behind this, it's important to focus on the high level. One is that the optimal efficiency is only a function of the merit. There's the figure of merit of this system of the coupled resonators. And the figure of merit, again, I'm not going to go over the details of the formulas, but if you do the math and the electronics and physics behind it, the figure of merit of this system that is transferring energy really depends on two factors. One is the coupling, which is K. The coupling is basically the amount of flux, the magnetic flux that the resonators are sharing or seeing with each other. And the other factor is Q, the Q of the two resonators. So if you don't have any control over the coupling, which you don't, as you move the resonators away from each other, the coupling decreases. The one way you can maintain the figure of merit or even increase it is by increasing the Q of either or both coils. Therefore, we drive the conclusion that resonators with high quality factor enable efficient energy transfer over distance. And on the chart on the right, you will see a chart of efficiency versus a figure of merit. So at figure of merit about 20, we can achieve 90% efficiency. Now with that, I want to go over some applications that we have been working on at WiTricity based on this technology, and give you some real-life examples, and also give you some view in terms of the roadmap and what is expected in the industry. So the first application is consumer electronics. The most obvious application is charging of your mobile phones over distance, basically putting it on a surface or putting it around an area, and it starts charging automatically. We are working with many device vendors to integrate this technology, and you should expect to see wireless charging for mobile devices early in 2015 as accessories for devices, and then I would think within 12 to 18 months as integrated into phones. We're also working with battery vendors to integrate this technology into batteries. So in the future, you will see wireless rechargeable batteries where these batteries will recharge wirelessly while in the device. You don't have to remove the batteries from your devices anymore. You just throw your device, let's say a remote or a game controller, into an area, a bucket or a surface, and the battery charges. Another application which is pretty obvious is wireless charging of devices, the peripherals around laptops, or even laptops themselves. The laptops can be placed on a surface and they get recharged without a wire. In conjunction with these applications, I'm sure you're aware of Intel's new initiative around the wire-free, where the next generation of laptops will not have any wires at all. And they won't have any wires for video, no wires for data, and no wires for electricity. And this is where Intel and WiTricity have announced a joint partnership to bring the wireless power into the market. The second application is automotive. In automotive, it's a very exciting application around wireless recharging of electric vehicles and plug-in hybrids. One of the challenges that car makers have with electric vehicles is the fact that users are required to plug the car in as they go into a garage or they park somewhere. And if they forget to plug it in, they may not have a car when they return if the battery is depleted. And this is a big concern for car makers because this requires a change in behavior of users. I can tell you that personally, I would probably most likely enjoy plugging my car in because I'm a technologist. But I can guarantee that my wife will forget to plug it in the car, and when the next day she goes and drives it and the battery is low, she will not be happy. Also, the concept of consumer electronic applications extend to automotive, where in-vehicle wireless charging is a key application. In automotive, we have also announced a partnership with Toyota, and Toyota is planning to offer this feature in the next generation of Prius plug-in hybrid. I think the latest announcement I heard from them was around 2016 models. Next interesting application is medical, where implantable devices primarily are going to be recharged by wireless charging. A big company we're working with, Thorotech, are working on the next generation of heart pumps called LVADs, the left ventricular assist devices, where these devices today, because of the amount of power they consume, they require recharging every week or every 2 weeks. And as a matter of fact, patients have 2 wires sticking out of their belly for this frequent charging. The next generation will have WiTricity's technology in there, and the patients can sit on a couch and we can charge that heart pump's battery over a distance of 20 centimeters. The same technology is getting applied to hearing aids, where you don't have to plug in the hearing aids to recharge a battery. You just throw the hearing aid into a bucket and it recharges automatically. And also medical carts, where in the operating rooms that power cord is a danger both in terms of infection and also convenience for the operating room staff. Finally, a lot of applications around military and defense. This is where we're working with many military contractors and organizations to put wireless charging in soldier gear. The first application that we're working on is around wirelessly charging the soldiers' batteries and providing an opportunity to reduce the battery weight for soldiers. From what we have seen, in some cases, soldiers carry up to 40 pounds of batteries to power up all these devices that they have, both on their helmet and their rifles, throughout the day. By providing wireless charging as soldiers go into different areas, or they go into the Humvee or the Jeeps that they have, and they can wirelessly charge the battery as they're moving from one location to another, you have an opportunity to reduce the size of the battery. We're also working on technologies where we are removing the wire from the soldier's vest to the helmet. I think it's called a lifeline. And there's a lot of danger if that power cord is broken. All the gear on the soldier's helmet won't have power anymore. We are going to wirelessly transfer power from the vest to the helmet. There are also a lot of applications in UUVs, the unmanned underwater vehicles, where during surveillance or whatever function they're doing, they don't have to resurface up to recharge their batteries. They can go and wirelessly charge the batteries at a station underwater. We have also done a lot of work in the military for robots in the battlefield, where the robots can come back to a station and wirelessly recharge themselves without the need for a soldier to come out and charge them and put the soldier in harm's way. So those are the applications. I have a couple of other slides. I wanted to share some knowledge and shed some light into the market landscape, and also talk a little bit about standards and what's happening in the standards world. First, the market landscape. Interestingly enough, the technology that we have is very new. However, the market is fairly fragmented and fairly crowded. So what I have done here, I have divided different companies and organizations that are involved in wireless power into a quadrant, divided by low efficiency versus high efficiency. So low efficiency is consumer applications, high efficiency is military and automotive applications and industrial applications. And then positional dependence, which means technologies that require tight alignment, and there are some use cases for that, versus technologies that are what I refer to as positional freedom, technologies where you can move the devices around easily and continue to use the applications. So if you look at positional dependence versus positional freedom, this is really inductive technology versus magnetic resonance. On the inductive camp, you have many companies that are focused around inductive and really niche applications for the inductive. And some are working on what I refer to as the first generation wireless charging for mobile phones as well. But in my view, those technologies are not going to enjoy a long life because the next generation of technology is coming out fairly quickly. Then on the right-hand side of the positional dependence versus positional freedom, you have different companies or organizations that are focused around magnetic resonance. We provide a foundational technology for magnetic resonance along with the reference designs and the consulting services to bring the product to market. RESONANCE, or Alliance for Wireless Power, is a consortium by many different companies that are standardizing the magnetic resonance. And ISO, SAE, and IEC also as well are organizations that are leveraging magnetic resonance primarily in the automotive market. And then there are many other companies that are working on a technology that I refer to as really RF. This is radio frequency, some form of radio frequency, or some sort of far-field radiation. Different companies are focused on that. The major challenge of that approach is low efficiency. These companies, from what I have heard, they are working anywhere from 10%, maybe 15% efficiency, which in many applications is very unacceptable, and that's why the focus is around low efficiency, low power applications. On contrast, they do provide a very large positional freedom, so you can move the devices around in a larger space at the cost of efficiency. Looking at the standards landscape, many different consortiums are working on standardizing this technology, and I think as an industry we have the opportunity to provide one common standard and really eliminate the need to carry different charges again. Because the wireless power, remember, the wireless power is you're transferring power wirelessly, but there's still technology behind it. And if we don't make interoperable technologies, we have not served the user base well, because at the end of the day, the consumers will end up carrying different devices for different wireless charging technologies. So with that, there are different consortiums that are working on somewhat different standards, but the good news is that everything is merging towards magnetic resonance. So starting from, again, I've created a quadrant versus based on low power, high power, and inductive versus highly resonant, which is magnetic resonance. There are, in the consumer side, which is the low power, this is the bottom left, there are two consortiums that have been involved in creating the standards for really inductive charging. This is Wireless Power Consortium, WPC, with a CHI standard, and Power Matters Alliance with a PMA standard. The challenge with this, with both of these consortium, is that their technology is inductive, and in my view, they do not provide the necessary use case benefits to consumers for it to take off. And I think we're seeing some signs of that. WPC has been around for many years, and we still have not seen the adoption of the technology in the marketplace. And the same with PMA. Now, as I mentioned, the good news is that the PMA, they have agreed to work with A4WP, the Alliance for Wireless Power, which you see on the top left quadrant. This is the alliance that is working on magnetic resonance based on WiTricity's technology, and with many major players in the consortium. On the board of Alliance for Wireless Power, you have WiTricity, Intel, Samsung, Qualcomm, IDT, and Broadcom as well as Geo Technologies. So major players are behind it. PMA is adopting A4WP, and we should see that taking off in the marketplace. And the same, where the good news on the high power is that every consortium is adopting magnetic resonance, and the reason is fairly clear. On the high power, positional freedom is key, as well as being able to charge with device sizes, electronics that is fairly small. In induction, you will require very large devices or coils to transfer power. So with that, I'm going to wrap it up. Again, WiTricity, we were formed based on an invention out of MIT back in 2005. The company was formed in 2007. We started the company to commercialize this very exciting technology, and with that, we provide reference designs for different power levels. We provide custom development and consulting services for our customers to integrate this technology into their products. We have a software tool called YCAD to accelerate this technology transfer by simulation and modeling. And really our goal is to accelerate this market and bring wireless power transfer for the general consumer and for their use. And at the end, I always like to say that our goal is to do for electricity what Wi-Fi has done for networking. And with that, I thank you for your attention, and I leave you with a quote from Arthur C. Clarke, the third law, which says, any sufficiently advanced technology is indistinguishable from magic. Thank you, everyone.
Thank you so much, Kaynam. We'd like to have a call for final questions from the audience. We will send them to Kaynam after the event. Please enter any last questions you may have in the navigation pane at this time. We've received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content found on our website, emclive2014.com or interferencetechnology.com. And you can also email us at info@emclive2014.com. We're very excited to announce EMC Live 2015 will take place next year, April 28th to 30th, so mark your calendars. Webinar attendees, if you have any more questions, please send us an email at info@emclive2014. A recording of this webinar will be available on our website, and we will also send a link to all participants shortly. Thank you for attending.